One of the main differences between strong and weak acids is that strong acids will fully dissociate, while weak acids will not fully dissociate. Because of this, weak acids can have multiple charged and uncharged species, while strong acids will fully dissociate and all be charged at equilibrium. You can minimize this effect by adding buffers. Buffers resist change in pH. They are made of a weak acid and their conjugate base. The weak acid absorbs hydroxide ions, therefore resisting a change in pH. A buffer can also be a weak base and its conjugate acid and absorb H+ ions. The first step in this experiment is to unscrew the cap on the pH meter. Once you've unscrewed the cap, be sure to check to make sure that the bulb on the end of the pH meter isn't cracked. To calibrate the pH meter, you'll first start by rinsing off the meter with deionized water. The pH meter needs two buffers to be calibrated. We are using a pH 7 and a pH 4 buffer because we are using an acid. You'll want to use your pH 7 buffer first in your calibration. To start your calibration, dip your pH probe in the pH 7 buffer and wait for the voltage to stop changing. Then hit 7 and then keep. In between buffers, be sure to rinse off your pH probe. Then place your probe in the pH 4 buffer. Wait for the voltage to steady out, and then press 4 and then press keep. Then you are done calibrating. Here are everybody else's examples of unscrewing and calibrating the pH meters. Once your pH meter is calibrated, use it to determine the pH of the different solutions. Our pH value for acetic acid was 2.19. For hydrochloric acid, the pH meter says 0.45, but changes off screen to 0.52. The pH for apple juice was measured at 3.20. The pH of orange juice was measured at 3.60. Here are all of our final values.